CBSE board, 6th class, mathematics is the subject and prepared by KV Sridhar, myself, chapter number 8, decimals. Chapter number 8, decimals. Example. Example for a decimal point. See, 45.6. 5 is in ones position, 4 is in tens position. We know. This is the decimal point. And after decimal, this place is called as a tenth position. What is that? Tenth position. Observe carefully. Okay? This is called as a tenth position. One more example. 17.591. We know this is in ones position. This is in tens position. This point is known as decimal point. And this is a tenth position. That means 1 by 10, tenth position. Next, this is hundredths position, 1 by 100. And this is thousandths position, 1 by 1000. Okay. This is how we are going to formulate the decimals. The place values. Once again, 1000.1234.5. Okay. This place is called as ones position, tens position, hundreds and thousands. Whereas after decimal, tenths position, hundreds position, 3 is in the thousandth position and 4 is in 10,000th position and 5 is in 100,000th position. Okay. This is how the place values of a decimal value will appear. Representing the decimal numbers on number line. See, 0 to 5 on decimal numbers. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 and 5. Okay. This is how we are going to represent the decimal numbers on a number line. Okay. See, this is one more example. 0.00, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, after that 0.1, or else it is called as 0.10. Similarly, 0.2 can be represented as 0.20, 0.21, 0.22, 0.23, 0.24, 0.25, 0.26, 0.27, 0.28, 0.29 and 0.3, or we can call this as 0.30. Okay, like this. Tell me, students, after 0.30, what numbers will appear? 0.31, 0.32, 0.33, 0.34, 0.35, 0.36, 0.37, 0.38, 0.39. Can you guess what the next number? It is 0.3. Yes, you are right. It is 0.4, or we can call it as 0.40. This is how we are going to represent the decimal values on number line. Decimals and fraction. 0.01 in the fraction form, it is called as 1 by 100. Okay, and 0.16 can be written as 16 by 100. After decimals, how many numbers are there or how many digits are there? That many zeros. Okay, 0.35 35 by 100, 0.43 43 by 100, 0.98 98 by 100. Like this, the decimal as well as fractions will be represented. Fractions as decimals, or decimals represented as fractions. Let us now try to find the decimal representation of 11 by 5. We know that 11 by 5 can be written as 22 by 10. Okay, this can be further made as 20 plus 2 by 10. Okay, and this can be written as 20 by 10 plus 2 by 10. Okay, this is equals to 2 plus 2 by 10, because 0 0 cancelled and 2 plus 2 by 10. That means since 2 by 10 is 0.2, it is 2.2. Observe carefully. We are just simplifying the numbers. 11 by 5 can be simplified as 22 by 10, and this 22 by 10 can be represented as 20 plus 2 by 10. This 20 can be written as 20 by 10 plus 2 by 10. So 2 plus 2 by 10 and 2.2. Decimals as fractions. 0.5 can be written as, I told you earlier, after decimal, how many numbers are there? Only one. So 1 0 we have to put. After decimal, how many numbers are there? Two numbers. So 2 zeros we have to put after 1. That means 100. After decimal, 3 digits are there, 638. So 638 by 1000. This is how the decimals will be represented as fractions. Exercise 8.1. Write the following as numbers in the given table. See, tens, ones, tenths. Okay. For the given data we have hundreds. How many we have? No hundreds are there. Okay. 0. Tens. How many are there? 1, 2, 3. 3 are there. Ones, only one cube is there. 1. And tenths, it is 2 we have. 1 and 2. And for the next one B, we have hundreds, 1, tens, 1, and ones, there are no ones, 0. So tenths are how many? 1, 2, 3, 4. Okay. Second problem. Write the following decimals in the place value table. 19.4, 0.3, we will see them all. The place value table is given as like this: hundreds, tens, ones, and tenths. Okay, for the first one A, how many hundreds are there? No hundreds, 0. Tens, 1, and ones, 9. Tens, 4. So 19.4. And for the problem B, hundreds, no, 0. Tens, 0. Ones, 0. And tenths, it is 3 is the number, that means 0.3. For problem C, it is 10.6. Hundreds, 0. Okay. tens 1, ones 0, again tenths 6, so it is 10.6. Next, for the problem D, 205.9, hundreds place 2 is there, tens place 0, ones place 5, and tenths place 9 we have, so that 205.9 can be represented like this using the place values. Next, problem number 3. Write each of the following as decimals. First one, 7 tenths. 7 tenths can be written as 7 into 1 by 10, that is 0.7. Second, 2 tenths and 9 tenths. 2 tenths plus 0 ones plus 9 tenths. That means 2 tenths means 2 into 10, 20, plus 9 tenths, that means 9 by 10. So 20.9. Understood? Okay. Next, 14.6. Directly we can write this as 14.6. 14.6. Next, 100 and 2 ones. 100 and 2 ones. 2 into 1. That means 100 plus 2. This is 102. 100 plus 2 ones. Okay. Next, 600.8. We can write it directly as 600. 600.8. Okay. Next, fourth one. Write each of the following as decimals. 5 by 10, 3 plus 7 by 10, etc. 5 by 10 can be represented as 0.5. Next, 3 plus 7 by 10. 3 plus 7 by 10 can be represented as 0.7. So, if you can add, it can be like this, 3.7. 3 plus 0.7 is equal to 3.7. Next, C, 200 plus 60 plus 5 plus 1 by 10. That means if you can add these three, 265 plus 1 by 10. 1 by 10 is 0.1. That is 265.1. Next, 70 plus 8 by 10. 8 by 10 can be represented as 0.8. So if you can add, we get 70.8. Next, 88 by 10. This can be written as 8.8. 2 by 10 is equals to 0.2. Next, 3 by 2. 3 by 2 can be written as, for our convenience, we are simplifying this as 3 by 2 multiplied with 5 by 5. That means 15 by 10. Since we have 10 as denominator, we can represent this number as 1.5. Next, 2 by 5. 2 by 5 can be multiplied as 2 by 2. We can get 4 by 10. This is equals to 0.4. Next, 12 by 5. 12 by 5 can be represented and multiplied with 2 by 2 to get 24 by 10, which is equals to 2.4. Next, 3 by 5, 4, 1 by 2. 3 into 3 by 5 can be represented as 3 plus 3 by 5. Okay, for the convenience, we have written this 3 by 5, we have multiplied with the 2 by 2. That means 3 into 2 is equals to 6 and 5 into 2 is equals to 10. That means 3 plus 6 by 10 value is 0.6, right? This is equals to 3.6. Similarly, 4 into 1 by 2 can be written as 4 into 1, 4 plus 1 by 2. This is equals to 1 by 2 into 5 by 5. This is equals to 5 by 10. That means 4 plus 0.5 is equals to 4.5. Okay? Just simplifying the numbers. Fifth problem. Write the following decimals as fractions. Reduce the fractions to lowest form. 0.6. 0.6 can be written as 0 plus 6 by 10. Okay, so 6 by 10. By cancellation, 2 will be cancelled in 6 3 times, and 10 will be cancelled in 5 times, 3 by 5. Or you can divide 6 divided by 2 by 10 by 2 is equals to 3 by 5. Next one is 2.5. 2.5 can be written as 2 plus 0.5. That means 2 plus 5 by 10. Okay. If you have taken 10 as LCM, 2 into 10 plus 5, that is 25 by 10. Okay. 5 can be cancelled 5 times in the 25, and 2 times in 10 to 5 by 2. So the lowest form is 25 by 10 is equals to 5 by 2. Next one, 1.0. 1.0 can be written as 1 plus 0 by 10. This is equals to 1. The lowest form is also 1 only. Next one is 3.8. 3.8 can be written as 3 plus 0.8. And 3 plus 0.8 can be written as 8 by 10. So taken as 10 as LCM, 3 into 10 plus 8, that is 38 by 10. Okay. Making the lowest form 38 divided by 2 and 10 divided by 2, this is equals to 19 by 5. 2 will be cancelled 19 times in 38, and it will be 2 will be cancelled in 10 5 times, so 19 by 5. Okay. Next, 13.7. 13.7 can be written as 13 plus 7 by 10. This is equals to 13 into 10 plus 7 by 10 by taking 10 as LCM. That means 137 by 10. 137 and 10 are co-prime, so the lowest form is also 137 by 10. Okay. Next one is 21.2. 21 plus 0.2. We can write it as like this. That means 0.2 can be written as 2 by 10. Taking 10 as LCM, 21 into 10 plus 2, that is equals to 212 by 10. The lowest form is 2 can be cancelled in the 212 106 times, and in the 10 2 can be cancelled in 5 times. So 106 by 5. Next one is 6.4. 6.4 can be written as 6 plus 0.4. That is 6 plus 4 by 10. Taking LCM as 10, 6 into 10 plus 4. That means 64 by 10. 2 can be cancelled 32 times, and 2 can be cancelled in 10 5 times, 32 by 5. It is the lowest form of 64 by 10. Next, problem number 6. Express the following as centimeters using decimals. 2 millimeters. 2 millimeters is equals to 2 by 10 centimeters, or 0.2 centimeters, because we know that 10 mm is equals to 1 centimeter. Okay. 30 millimeters. 30 millimeters same. 30 by 10 is equals to 3 centimeters. Next, 116 millimeters. So it is 116 by 10. That means we can write this as 16 plus, 11 plus 6 by 10. Okay, that means 11.6 centimeters. Next one, see, 4 centimeters, 2 millimeters. That means 4 plus 2 by 10. Okay, 4 centimeters plus 2 millimeters can be written as 4 plus 2 by 10 centimeters. That means we can write it as 4.2 centimeters. Next one is 162 millimeters. We can write directly 162 by 10 centimeters. We can write this as 16 plus 2 by 10. Okay, this is equals to 16.2 centimeters. Next, 83 millimeters. 83 by 10 centimeters. That means 8 plus 3 by 10. That means 8.3 centimeters. Problem number 7. Between which two whole numbers on the number line are the given numbers lie? Which of those whole numbers is nearer the number? First one is 0.8. 0.8 lies between the whole numbers 0 and 1. Okay. Next, 5.1. 5.1 lies between 5 and 6 clearly. Next, 2.6 lies between 2 and 3. Next, 6.4 lies between 6 and 7. Next, 9.1 lies between 9 and 10. Next, 4.9 lies between 4 and 5. Okay? Next problem, show the following numbers on the number line. Show the following numbers on the number line. 0.2. See, from 0 to 10 we have here this point A represents 0.2. Okay, 0, 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and 1. Okay, next 1.9. So from 0 to 1, this is the picture, 0 to 1. Okay, and from 1 to 2, just before 2 we have 1.9. This picture B represents 1.9 just before 2. 1.1 just after 1. Okay, in between 1 and 2 it was divided as 10 segments, 10 points. Okay, just immediately after 1 we have 1.1. So point C represents 1.1. 2.5 for the number line from 0 to 3. In the middle of 2 to 3 we have 2.5. So point D represents 2.5. Question number 9. Write the decimal number represented by the points A, B, C, D on the given number line. Okay. If you can count from this, it is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7 and 0.8. Okay. So point A represents 0.8. And similarly, after 1, 1.1, 1.2, 1.3. So B represents 1.3. See carefully. C represents 2, 2.1, 2.2, 2.2. Okay. And D represents just before 3. So it is 2.9. I am not counting. Just before 3 means 2.9. Okay. Question number 10. The length of Ramesh notebook is 9 centimeters 5 millimeter. What will be its length in centimeter? We have to convert. Length of the notebook is 9 centimeter 5 millimeter. That means 9 plus 5 by 10 centimeters. Okay, making all into the same units. That means 9 plus 5 by 10, which is equals to 9 plus 0.5 centimeters. This is equals to 9.5 centimeters. Next, question B. The length of a young gram plant is 65 millimeter. Express its length in centimeters. So 6 plus 65 millimeter can be written as 65 by 10 centimeters. So it can be written as 6 plus 5 by 10 centimeters. That means 6.5 centimeters. Okay. With this, we have completed this exercise 8.1.